energy, carbohydrate, coal, petrol, natural gas. Today we're going to talking about the topic of energy as for fuel. Now let's start. Throughout our human history, we use wood as a major fuel for the past 1,000 years. But until the last 200 years, we start to use fossil fuel. The Industrial Revolution, we start to use fossil fuel as coal, oil, and natural gas. That's become the major fuel that we need. Fossil fuel. Why we use fossil fuel? Because fossil fuel have high energy content, low cost, and very convenient to use. Now let's look detail. When we look onto the fuel, there is two main types. One is the biofuel, which is come from burning wood or leaf. Another type is the fossil fuel, like we burning coal, oil, or natural gas. And now we're going to look onto the difference of these two types. First, we look onto the difference in energy aspect. Now let's see. In energy aspect, biofuel have lower energy content than fossil fuel. So biofuel, the energy content is lower than fossil fuel. Fossil fuel have higher energy content. And I demonstrate by one example. If one day you go to barbecue and maybe you collect some branches from the tree and some dry leaf, and you put it to help you to burn, and you will find that you have to add more and more and more. Each time you only last for a couple of minutes, and you have to add more. And so this is the biofuel that you're using. But in case if you put fossil fuel, like you have a handful of coal and you put it onto the barbecue, you find that you don't need to add much. Once the coal light up, it last you for an hour or maybe 2 hours, and you don't need to keep on adding more and more and more for every 5 minutes. This to demonstrate one thing. Biofuel have a lot lower energy content than fossil fuel. Now, after we look onto the energy aspect, now let's look onto the molecular aspect. If you look onto biofuel, fossil fuel different, and they have one thing in common, they both have a backbone. This is called the carbon backbone, like a fish have a backbone. Look at this fish backbone. This is the backbone made of carbon, can be in a chain form or it can be in a ring form. Or fossil fuel the same, it also have a fish backbone, carbon. And this we call carbon backbone. But what's the difference? The difference is biofuel have a lot of OH because they're on the land with oxygen, have a lot of OH. Biofuel have a lot of OH. And we call this carbohydrate. Carbohydrate means CHO, hydrate, OH. So carbohydrate, that's what you heard of this term many times. And when we look onto fossil fuel different. Fossil fuel don't have the O. Fossil fuel only have the H. That is the CH. And you call hydrocarbon. Hydrocarbon. And Another aspect important for you student of carbohydrate, this is a polar molecule. Why? You have the OH, which is unsymmetric electron pooling. So they have a positive negativeness. And this make it form hydrogen bond with neighbor molecule. As to hydrocarbon, they are a non-polar molecule. Hydrogen and carbon are very symmetric in electron pooling. So they form dispersion force with the neighbor molecule. So now let's examine more detail, and we start off with the biofuel carbohydrate. Now let's talk about glucose. In burning wood, the formula glucose with oxygen give carbon dioxide and water, and this process is exothermic. Exothermic means it releases energy. The other side, photosynthesis, is they just do the other way around. Carbon dioxide add water, it turns back to glucose and oxygen. And this process is endothermic. And it requires the input of energy. And now let's look onto the enthalpy graph. I hope students still remember this enthalpy graph. So you can see glucose with oxygen originally as a high energy content compound. Now they release energy. And become carbon dioxide and water, which contain less energy. So this energy release represented by a minus sign. On the other side, photosynthesis, you see originally this carbon dioxide and water is a low energy content compound. And by using the sun energy, you add energy in. Now they become a high energy content compound, glucose and oxygen, high energy content. So you have to add energy in. So you have to add delta H. So student, hope you still remember this endothermic, exothermic on enthalpy. Now let's talk glucose. Glucose, formula C6H12O6, also called carbohydrate. Student, please remember the name, the formula, well, you require. Glucose have two types, two main forms. One form of glucose called starch. We use it for energy, fuel energy, food to give us energy. And that the type is called cellulose. Cellulose, which is a plant structure. And now I'm going to tell you the difference. Starch usually is stored in plant, like the potato you eat, corn, rice, wheat, or noodle, they all come from starch. And what is starch made of? Glucose. Look at this, glucose. And this is a glucose. And this glucose on the bottom picture, this is a single glucose. This is a single glucose. And this glucose, they are in a spiral form. Like a cotton fluffy ball, or it can form into a ring form. And all these use it for energy. It's a form of glucose. They are in a complex structure. We use it for fuel energy, so that's why we eat it to give us energy. Now we look on cellulose. Cellulose look very different. This cellulose, they are also made of glucose. This is glucose, same as earlier glucose on that side. But these glucose are in a linear form. They are in a linear form. Linear. So this cellulose, they are used for plant structure. As on the cellulose fiber, they have many bundle of parallel fiber. And because of that, you can see the wood fiber of this linear structure, and they provide the strength. So that's happened onto all the wood structure, the plant structure, and the leaf. They are all on this structure. They form into this flat ribbon-like strand and give very strong and very rigid. And so you can see that what is the difference? This one is linear. This one is spiral, in spiral form. And what makes them different? Even they both are glucose. The structure. Look, this linking process of this link is called alpha 1,4 linking. The other process, this is called beta 1,4 linking. And that's all the difference. They link differently, but they both, each basic unit are glucose. Now, after we talk glucose, I'm going to talk fossil fuel. Fossil fuel, students, you always have a misunderstanding. You thought something dead for a long time and you become fossil. Actually, this is wrong. It's nothing like that. And in case if this is a land animal, let's look onto the picture of this land animal. When a land animal is dead, what will happen? The bacteria will come and decompose it. And this bacteria is called aerobic bacteria. This aerobic bacteria is using oxygen to decompose this dead body. And this process usually are very fast. As a matter of weeks, all this dead body will be gone. And what's left? Nothing left. Nothing left. All will be gone. So you're not going to form any fossil on the land animal dead body. Then now let's look onto another situation. In case if the dead body is deeply buried, and what I mean by deeply buried, I don't mean to dig a hole to bury. I mean to 1,000 meter deep. How can you dig up 1,000 meter deep hole? That's usually come from the volcano, landslide change to bury this animal alive. So in that situation, now in the deep underground, they will have no oxygen. When they have no oxygen, you are subject to another type of bacteria. This bacteria is called anaerobic bacteria. Anaerobic, no oxygen bacteria, anaerobic. This bacteria will decompose this dead body, but not by using oxygen. If they decompose not by using oxygen, this process is a lot slower and it takes a lot more time. And this is the one that you end up to be fossil fuel. And that's the condition. You can compare the difference. On the land bacteria, that those aerobic bacteria, they decompose it by using oxygen. These processes are very fast and not going to form any fossil. And on the other side, forming fossil is done by this anaerobic bacteria, and the process are very slow. It takes thousands of years, and by not using oxygen. And usually you have to add heat and pressure, as from the landslide and the volcano, that eventually it ends up to become fossil fuel. And that's what we talk fossil fuel. So if you compare the process, what's fossil fuel requirement? Number one, long time. Number two, anaerobic bacteria, not using oxygen. Number three, with heat, pressure to form into fossil. Now I'm going to talk about coal. What is coal? Coal is a plant material. This plant material decomposes in a warm, muddy swamp, and these usually are no oxygen, lack of oxygen environment, and this will take millions of years to become coal. And now let's examine more detail. Now I show you of this process. The step is, first they will call the peat. Peat usually onto the upper level. Then you call brown coal lignite. Then further process into black coal. And the best quality coal is called anthracite, which is a hard black coal. And when we try to drive, basically all the plant material, this glucose ring, you will see what it will end up to become all the OH disappear. It only left with a carbon backbone. That's what we're driving. The point is we want to have a maximum amount of carbon and remove every other content. And now let's start. Okay, we start off from the beginning. For this plant, this rotten dead plant, leaf, bark, they bury into the swamp with no oxygen. Step 1. Initially, this organic material will convert into peat by anaerobic bacteria. And this peat is a soft, spongy material. Have you seen the peat? Yes, you might. If you see sometimes in the gutter, there is that black sticky stuff that is very close to it. It look like that. Those black stuff in the gutter. And those gutter, they have quite a high moisture. They're wet with a lot of other substance. Do they have much carbon in it? Not very much, very little. And then the next stage, it would further decompose by this anaerobic bacteria to reduce all the volatile compounds like the water, the methane, carbon dioxide, and any other content. And now you can see the carbon contents is start increasing. The carbons go up now. The other substance going down. So now this stage we call a brown coal lignite. Usually they will be on a bit deeper layer. Then another stage, further timing, they will become the black coal. This one you have to subject to extreme heat and pressure. For example, because of the geographic change for the mountain causing the pressure and extreme heat. Now and further, they will remove those volatile compounds. And now you see the carbon content go further up and the other substance volatile content go further down. Now at this stage, this we call the black coal. This black coal. The best quality of coal is called anthracite. From the soft black coal become hard black coal. And the content of it, they can reach to 90% pure carbon with very few other content. And this black coal is the best quality. And you can see certain rule. The deeper they are, the better the quality. So usually onto the top layer, you only can get the peat or the brown coal. And you want to have the best quality coal, you have to drill very, very deep to have the anthracite. And the anthracite, usually in Australia, we export it to Japan or Asian country because of they have very high energy content, so you can sell for good profit. So you can see this coal starting from peat, which have very low carbon content, become brown coal, which have a higher carbon content, become black coal, have even higher carbon content, and finally become anthracite, which have the highest carbon content. Now let's talking about crude oil and natural gas. What's crude oil, natural gas come from? They come from the marine organism. The marine organism, that is usually they are accumulate as an organic sediment in the ocean. So you can see 300 to 400 million years ago, those small marine organisms that die. And then 50 to 100 million years ago, this in the porous sediment rock that is sipping here. And until today, it be trapped as an oil and a natural gas. Student, when you see I talk oil, I talk crude oil, or commonly we refer to petrol. So here, the crude oil and natural gas will trapping in between here. So the rule will be just like the old rule we talk. Long time, over 1 million years, under the anaerobic bacteria, under subject to heat, pressure, at great depth, which reduce all the organic material into hydrocarbon. And this hydrocarbon will trap into the layer of this porous sedimentary rock. So that's what the crude oil and natural gas come from. And now for the following session, I'm going to go detail about crude oil and natural gas. Let's continue.